So let's look at some cubic equations and how they relate to the factor theorem and functions. So the easiest way to do this is just through an example. So I'm going to take this question 4 here, and I'll explain everything using question 4 as an example. So question 4, x cubed minus 3x squared minus 10x plus 24 equals 0. So this is the question that we're looking at. So we have a cubic function, and we have the cubic function equals to 0, and we're trying to solve this. So what does this mean? Let's take a closer look at the basics. So here we have a function. You can see the function on the left hand side here, and this is the same function, x cubed minus 3x squared minus 10x plus 24, as we're dealing with. So as you know, functions take x values and convert them into y values, and this graph represents the relationship between the x values and the y values. So if we take any point on the function, this point xy, this point is free to move. Every point on a function has an x value and a y value. So we're going to settle this point here at the value of x is equals to 3. So when x is equals to 3, what is the corresponding y value? We can kind of see it from the graph, but we also need to understand how to work it out algebraically. So that's what I'm going to do on the right hand side here. We have the function y is equals to x cubed minus 3x squared minus 10x plus 24, and I'm interested in what is the y value for an x value of 3. So let's have a look. So if I've got an x value of 3, my y value, y will be 3 cubed minus 3 times 3 squared minus 10 times 3 plus 24. So we just continue this. Y is equals to 27 minus 30 plus 24. So y is going to equal minus 6. So you can see this is going to be the point 3 minus 6. And that's what you can see here in the graph, that for an x value of 3, the y value is minus 6. So you know how to represent that graphically and how to figure it out algebraically. Let's just do one more quick example for you here. Let's move this point along and let's leave it settled where the x value is 1. So when the x value is 1, what is the corresponding y value? So same again, what we're going to do is just fill 1 in for x. So if x is 1, the y value, 1 cubed minus 3 times 1 squared minus 10 times 1 plus 24. So y is going to be 1 minus 3 minus 10 plus 24. So that is going to be 12. So we have the point 1, 12. So as you can see here, when the x value is 1, the y value is 12. So let's go back to the original question here, x cubed minus 3x squared minus 10x plus 24 equals 0. So what this is interested in is we have the function here, where is it equals to 0? What x values will give you a y value of 0? So we can see them from the graph here, the 3 roots we call them, where the function cuts the horizontal axis. These are the 3 points where the function equals 0, and these 3 x values will be the solution to this cubic equation. But we need to understand how to solve for these values without the aid of a graph. So the idea is we're going to find a root by trial and error. Now, what do I mean by a root? If we go back, the root is where it cuts the x-axis. We are looking for 3 roots. Because it's a cubic equation, we're looking for 3 roots. And the first thing we have to do is find the first root by trial and error. So that just means filling in different x values and seeing if it all tidies up to 0, if the output or if the y value is 0. So, you know, the first thing you would try is x equals to 1. Now, we already know that when we tried x equals to 1 a while ago, that the output was 12. So we know that when x equals 1, y is going to be 12. So we know x equals 1 is not a root. So next thing we'll try x is equals to 2. So if x is equal to 2, trying to find the y value, y will be 2 cubed minus 3 times 2 squared minus 10 times 2 plus 24. So the y value will be 8 minus 2 squared is 4 times 3 is 12 minus 20 plus 24. And when you solve that, that's y is equals to 0. So the point 2, 0 is a point on the function, which means x equals 2 is a root. Now, this takes us to the factor theorem. So we have a theorem, the factor theorem, and this tells us that if the f of k is 0, so basically if you put in some x value into the function and it gives you 0, in other words, that value, whatever that number happens to be, that value must be a root of the function, right? So if you fill a value in and you get 0, that value must be a root of the function. And if that is the case, then x minus k is a factor of the polynomial, all right? So in our example, we had the polynomial y is equals to x cubed minus 3x squared minus 10x plus 24, and we just showed that x equals 2 is a root. That's what I was showing you right here. We filled in x equals 2 into the function, and we ended up getting an output of 0, which means x equals 2 is a root. So the fact that we know x equals 2 is a root, because of the factor theorem, we know that x minus 2 is the factor. X minus 2 is the factor. The next step is then to do some long division. So we're going to take the function that we have and we're going to do some long division to help us factorize it, to find the other factors. Now remember, we just found out that x minus 2 is a factor of the function. So going back to my long division, I know that x minus 2 should divide into this function. So then we do our long division, x into x cubed, we got x squared times x is x cubed minus 2x squared. So we've got minus 1x squared minus 10x, x into minus 1x squared minus 1x. X into minus 12x, that's minus 12. So I know you guys know how to do long division, which is why I'm flying through it. What I'm more interested in is the result of this long division. So we have divided x minus 2 into x cubed minus 3x squared minus 10x plus 24, and this was the result. So this quadratic right here contains the other two factors. So my next step is now to factorize that quadratic. So I shall do that over here. We have x squared minus 1x minus 12. If I factorize that, I got x minus 4. And I will get x plus 3. So they are the other two factors in this function. All right, and if we solve the equation and get the roots, x equals 4 and x equals minus 3 are my other two roots. And that's what we can see in the diagram. We have x equals 4, there's our x equals to 4, x equals to minus 3, there's our x equals to minus 3, and we already knew that x equals 2 was a solution because we found that out in the trial and error that we did right here. So that is our three solutions to the cubic equation. X equals 4, x equals minus 3, and x equals 2. So this is how you solve cubic equations and the connection between cubic equations and the factor theorem. Remember the factor theorem, if f of k equals 0, that's if x equals k is a root, then x minus k is the factor. And we had our example where x equals 2 was the root, and therefore x minus 2 was the factor. All right, so in summary, for cubic equations, how do we solve it? Well, we found a root by trial and error. That's the first thing we did, find a root by trial and error. Then we changed that root to a factor. Then once we had the factor, we did some long division. And then the result of long division, if you remember, left us with a quadratic on top, and we factorized that quadratic to get the remaining two roots. So factorize the quadratic to get the remaining two roots. So that is how you solve cubic equations. the best thing for you guys to do now would be to look back at the question sheet, try some of these questions. The solutions are online, and please subscribe for more details and worked out solutions.